Okay, so before we go any further, this idea is very important, and in Math 12 is also very important. So, questions? Any comments, concerns? Anything out there? I know it's 2:15 on a Friday, so you're probably just like, no, my brain went out the door. The last bell that let me have a break, it's gone. I came back into class, my brain didn't. Yes?
If the radius wasn't 1, would that significantly change sine theta over cos theta?
It would not, because then, a great question. Let's say the radius was 2, okay? So if the radius was 2, then what I'd have here would be y over 2, and I'd have x over 2. And then if I go y over 2 divided by x over 2, I'd still get y over x, because those would cross out. So it doesn't matter what the radius is, we'd still have that relationship. But the reason we like working with the unit circle is math is simpler when you're using ones. So that's why the unit circle is convenient. Okay? But what we should see now is we can talk about the sine and the cosine as the x and y coordinates on the unit circle. So this is the cosine of x, and this is the sine, the cosine of that angle, which is theta, and the sine of the angle theta. Okay? So for example, you should be able to tell me without your calculator now, what's the sine of 90 degrees? How did you get that? Somewhat remembered? Somebody else said 1. It is 1. Why? Because I put it in my calculator? Well, let's take a look at where's 90 degrees, okay? Here's 90 degrees. Okay, so where would I be at the unit circle? What's the coordinates right here? What are those coordinates? 1 is a coordinate. Which one? It's 0, 1, right? The two of them would be 0, 1. So that means the cosine of 90 is 0. The sine of 90 is 1. So even though we don't have the cosine and sine button on the calculator there, we can actually find some of them. Okay, one more time. Let's try 270 degrees. Okay, what's the sine of 270?
Just a question, but then wouldn't that make the tan of 90 1 over 0?
Ask your calculator what the tangent of 90 degrees is. Make sure you have to be in degree mode, right? If you're in radian mode, then it would be pi over 2. Tangent pi over 2. So what happens when you ask for the tangent of 90 degrees? Error, because you're dividing by 0. 1 divided by 0. Okay? So you're right, there is a problem, and that's still captured in this relationship. You're just trying to bust that up, right? You're just looking for ways to... Good, okay, that's good. That's the way a good mathematician would think. Okay, but what if I'm at 270 degrees? Here's 270 degrees. Yeah, the sine is going to be -1, and the cosine is going to be worth 0. Okay? So make the connection in your head that those coordinates are the same as the sine and the cosine. Okay? Here's how we use them. Okay. So let's think about this. We're going to fill in the ratio for each thing. Okay? So sine, let's just remind ourselves that the sine of theta, that's the y coordinate, that's the x coordinate, and that's y over x. Okay. So if I'm in quadrant 1, will sine be positive or negative? How do you know? You're right, it is positive, but how do you know? It's because the y coordinate's positive. It's the same thing, right? It's above the x-axis. So you're right, in the first quadrant it's positive. What about the second quadrant? What will the sine of the angle be if it's in the second quadrant? It will also be positive. It's still above the x-axis. Okay. Third quadrant? Good, it's negative. And then finally in the fourth quadrant? Okay, you try filling in cosine. See if you can use the relationship. Okay, so cosine. Can you fire them off for me? 1, 2, 3, 4. That's right. Okay, so again, cosine is the same as the x-coordinate. If the x-coordinate's positive, so is cosine. Okay. So it's easy to get the tangent because all I have to do is divide them. Positive divided by a positive is a positive. Positive divided by a negative, negative, positive, negative, negative. So that's how I can get the tangent.
for cosine, like for quadrant 3, is it on the left side?
Oh, sorry, it should be negative positive, right? Yeah, made a mistake there. Maybe Connor said it right and I just didn't listen to him properly.
No, I said it wrong.
Oh, okay, well there we go. Okay, so there we go. Right, because if you look in the quadrants, you got 1, 2, 3, and 4. It's here where x is positive, which is 1 and 4. My apologies, but that means tangent changes slightly too. It would be positive, negative, positive, negative. So maybe you just looked at the other chart on your sheet. Okay, so let's figure out here. Who's positive in quadrant 1? Well, they all are. Okay. Who's positive in quadrant 2? The sine is. The tangent is here. And the cosine is here. Okay, so there's a lot of questions where we need to know whether a question has a positive or negative answer. So we need to know whether the sines, cosines, or tangents are positive or negative. So this is not a convenient way to remember all sine, tangent, and cosine for quadrants 1, 2, 3, 4. Well, that's one of the acronyms I've heard. So here's how you can write it. One of them I've heard is all suckers take, what was it? Calculus. Sometimes I hear chemistry. I guess it depends on. Any other ones you've heard? Cast. I'll tell you. I'm going to do that one last. I'll tell you why in a second. Another one I like is this one's a little bit more PG. Add sugar to coffee. Okay. In the final picture, though, cast rule. Here's why I don't like cast. Cast rule goes 1, starts down here. So the cast rule goes like this. So cast helps you remember because it's C-A-S-T, but it starts in quadrant 4. It doesn't start in quadrant 1, where the other acronyms start in quadrant 1, right? Each word goes along with the quadrant. Okay, whereas this one's off by 1. So however you choose to remember it, that's fine, but you do need to remember them. Okay, so here's the kind of thing that Math 12s will be faced with. If the sine is negative and the cosine is positive, what quadrant are you in?
4.
Okay. I can't do it in my head. I don't know how you guys, maybe it's just because I'm older than you, but here, if I'm negative, what I do is I go like this. If sine is negative, that means I have to be down below. And then I say, okay, if cosine is positive, I have to be over here. So the only one that agrees on both is quadrant 4. So yes, this is a quadrant 4 angle. Okay. What about if sine is negative and cosine is negative? Both are negative. It may help you to draw the little scale like I did here and decide. Any ideas? 3? Yeah, so again, I would start by saying, if sine is negative, I've got to be in these 2 quadrants. If the cosine is negative, I'd have to be in these 2 quadrants. So that's the one which has both working. So it's going to be quadrant number 3. Okay. So I think I'm going to, maybe I'll pause our tape here and we'll